Hello everyone, today we are going to talk about the depth first search algorithm, an algorithm to traverse graphs. This algorithm, the DFS, it's a graph traversal algorithm that, starting from a given source vertex, visits all vertices that are connected to the source vertex. It traverses the graph in depth. This means that explores a branch completely before moving to a different branch. This is described usually recursively, but it can be implemented iteratively using a LIFO, a stack, that simulates the call stack that we have in the recursive case. To explore all the graph, we should repeat the DFS from each vertex, and we are using again a set called visited as we did in the DFS case. Let's take a look at the algorithm. Here we have the initialization of the visited and the predecessors dictionary. We have here the recursive method, and here the for loop that will launch the recursion. For each node, if this is not visited, we call the DFS visit method starting the recursion. For each call, we mark this node as visited. We iterate over the adjacents of this node. If these are not visited, we call again recursively the DFS visit and starting the process again. So this will explore a branch in depth. This is what is called a depth first search algorithm. Let's take a look at this example. Here we are using this directed graph, and starting from A, we can launch the recursive call. Here we have nodes that are adjacent to A, B, C, and G, so we visit first B. From B we can go to F, then we visit F. From F we can go to H and D, then the DFS visits H. B is not considered here because this is already visited. As H has no neighbors, we can continue iterating over the adjacents of F and then visiting D. From D we can go to E, and from E, as this has no neighbors, we can visit the second adjacent, that is G. Now we have covered all the nodes that come out of D. We have covered the nodes that come out of F, B, and from A we can visit C. So in this case we are continuing the iteration of the nodes that are adjacent to A. So finally we visit C. This DFS implies a path that covers all the nodes, and it is usually represented as a tree, as you can see here. We have explored a branch completely, and then we have visited the pending nodes. Thanks for watching, and see you in the next video.